Okay, Kipsters, before we get started today, just want to remind you of some of the details around what's going to make your team the most successful moving forward. So one thing to think about is definitely when you're in your groups, making sure that you're really focused in on everybody learning. If any point in time you or someone in your group feels like things are going too fast and they need to slow down and see what's going on, make sure that you're pausing the video to allow them to catch up. Everybody on the group should be on the same page. Additionally, if there's ever anything that you write down and you're a little bit confused about it, make sure that you raise your hand, reach out to your group, and have somebody within your group explain what you've just written down, so you're really making sure that you understand. The part of this group thing that's really going to work out for you guys is the fact that you are in a small group and you should be comfortable asking any questions at any point in time throughout the lesson. If it's a question that nobody in your group can answer, then make sure that you've made a note of it so you can ask that question later on in the period. So moving forward today, the other piece to worry about is thinking about a lot of the reason for the group is to engage you in having discussions and working within your groups and having debates within your groups. And that's really what's going to deepen your learning. That's part of what the Common Core curriculum is all about. So please make sure that when you're asked to do something on your own or independently, that you do pause the video to go ahead and work on it within your teammates before you open the video and continue the video to check the work and the discussion that you and your teammates have. So with that, let's go ahead and look at today's Do Now. Really today's Do Now is some reminders of some things and some beginning pieces of some things of what we need to do today. All right, the first one asks us what the area of a triangle is, the formula for the area of a triangle. So the area of a triangle, many of you know it as base times height divided by 2. That can also be rewritten. That's the same thing as saying 1/2 of the base times height. And if you think about this as a fraction, base times height over 1, you can see that's where we get that base times height over 2 from. So in its most basic form, I'm going to call it 1/2 base times height, which is answer choice C. All right, what is the area of the figure below? So this is your opportunity to practice using that particular formula. Area of a triangle is equal 1/2. The base and height, one thing to know about base and height of triangle is that they have to be perpendicular to each other. They have to be at a 90-degree angle. So a lot of times we'll see a triangle that looks like this, and a lot of people will tell me that this length up here is the height. Well, it's not the height. The height would be perpendicular to this base, which means that the height line is actually going to be out here. All right. So that's just one thing to kind of think about moving forward. However, these are pretty straightforward. We have 1/2 of base times height is 1/2 of 3 times 4. So that's half of 12, which is equal to 6 centimeters squared. And finally, what is the combined area of the two figures? Well, this is just that exact same figure that we already saw. So the area of this triangle is equal to 1/2 of base times height, which is equal to half of 4 times 3, which is 6. And for this one over here, this is a rectangle, so our area of a rectangle is equal to base times height, or in this case 4 times 3. That's 12. So our combined area would be 6 plus 12, which is going to be 18 square centimeters. And that's kind of the idea of what happens when we put figures together that may contain multiple pieces. And that's really the crux of what our lesson looks like today. We're going to be looking at a couple of different shapes and how we can find different areas. Hipsters will be able to decompose figures on a coordinate grid to find the area. All right, let's talk about this word decompose here. Decompose means to take apart. We're going to take apart some figures on a coordinate grid in order to find the area. All right, so first one we're going to look at here is we're going to look at this figure on the coordinate plane. There's actually some directions that I want you and your teammates to be able to follow within your groups without my particular guidance. It's more of an exploration here for this particular shape. So we're looking at this shape. The shape is a parallelogram. There is a formula for parallelogram that I'll share with you here in a moment. But first I want us to explore a different way to find the area of this parallelogram. So the first thing it asks you to do is write the ordered pair of each of the vertices next to the point. So for instance, I'd be starting with this point here, point A, and I'm going to write the coordinate pair, which would be -3, -4. Go ahead and do that for all the coordinate grid, or all the coordinate pairs. And then once you've done that, go ahead and start through B, C. C is asking you to find the area of the rectangle that you draw in part D. Then I want you to find the area of each triangle. So when you draw that rectangle, you're going to see that you're going to create 2 triangles. So you're going to find the area of each of those triangles. They're going to use those areas to find the area of the parallelogram. So once you get to that point, you're really going to probably have to work together with your team to see how you can use those triangles and the rectangle you've drawn to find the area of the parallelogram. And then you're going to want to check with the video to see if you guys are on the right track here. All right, so go ahead and work through all of that, parts A through E here, in order to correctly work through today's work. And then once you've finished, then come through and check in. If you get stuck somewhere in the middle and nobody on your team can figure it out, then you can go ahead and check in at the video and get the video going. Alright, so considering that your group has already gone through and done all this, I'm going to work through this pretty quickly, and it really should just be a quick check on your work. So I'm going to go through and label these points. Point D here is at 2, -4. C here is at 5, +2. And B is at 0, +2. So those are our 3 points. Next it tells me to draw a rectangle surrounding this. So there's a vertex at A and C, so I want a rectangle that's at vertex A and C. So in order to make this a rectangle, we're going to point here and a point here. Label the 2 triangles in the figure as S and T. So this is going to be S and T. Doesn't really matter which one you labeled as which. As we come over here, it says to find the area of the rectangle. So the area of a rectangle is equal to base times height. And so looking at the rectangle here, counting off, it's 1, 2, 3, 4, 5, 6, 7, 8 units long. And 1, 2, 3, 4, 5, 6 units high. And so my base times height is going to be 8 times 6. So the area of the rectangle is 48 square units. All right, coming over here, find the area. Oh, that was the area of the rectangle. This should have gone here. Find the area of each triangle. Well, looking at the triangles, I see this triangle is 1, 2, 3 by 1, 2, 3, 4, 5, 6. And this one is also 3 by 1, 2, 3, 4, 5, 6. So these are actually going to be the same. So the area of triangle S is 1/2 of base times height, which is 1/2 of 6 times 3. Half of 6 is 3 times 3, which tells me that this area is equal to 9. Area S is equal to area T because they are the same size triangle. So area T is also equal to 9 units squared. All right. find the area of each triangle. Again, looks like I got ahead of myself. This should have been down here. And use these areas to find the area of the parallelogram. So this is what we have to think about here, and this is where we have an idea of what I call negative space. All right, so we have this whole rectangle, and then if we take away the area of these two triangles, what we're going to be left with is the area of the parallelogram. So the area for P is the same thing as the area of the rectangle minus area S minus area T. So that would be 48 minus area S was 9 minus 9. And so when I do that in total, that's going to give me 30 units squared. Alright, so looking at this second part, it asks us to draw triangles S and T to connect to figure R so that you can create a rectangle that is the same size as the rectangle that we created in the first coordinate plane. Alright, so what we see here is that we have a rectangle right now that is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6. So looking at that, I know that if I go back and recount, I need to add triangles S and T such that I get a rectangle that is 1, 2, 3, 4, 5, 6, 7, 8 by 6. Alright, so the side that's 6 I really don't want to add on to, so I know that I want my triangles to be oriented vertically. I just need them to be 3 units away. And fit into this space to be 3 by 6. And so it doesn't really matter which one we label, we know they're the same. Both of these look like they're 3 by 6. So I'll label this one S and I'll label this one T. Okay, so this is done. Check. We have that on the coordinate grid. It says find the area of rectangle R. So go ahead and do that on your own and tell me what rectangle R and rectangle P have in common. Go ahead and do that, and then we'll check back in about what this actually means. So pretty quickly you should be able to identify that the area of R is equal to base times height, since it is a rectangle, and the base and height of that rectangle are 6 and 5, so 6 times 5 is equal to 30. So what do areas R and P have in common? You and your group should have identified that both AR and AP are equal to 30 centimeters squared, or 30 units squared. They have the same area. So what does this mean? Well, the important thing to look up here is that angle P, shape P and parallelogram P and rectangle R are the same area. And what we recognize here is they both could come from these same size rectangles that we started with, and both of them, if we take away triangle S and T, it's the same thing. So we notice that if we look back over at our parallelogram, go ahead and count out what is the base and what is the height of that parallelogram. Count that out now. So when we look at that, we see that they both have, it also has a base and a height of 6 and 5. So as we come over here and we count, just the base of this is 1, 2, 3, 4, 5. So we have 5 there, and counting up, 1, 2, 3, 4, 5, 6. So we actually can find that this is proof that the area of a parallelogram is also equal to its base times its height. Alright, so let's move over to the other side. We're going to talk about some different ways to look at some of these figures. Alright, this first figure is just to warm up. You and your group should be able to do this one on your own. So go ahead and pause the video and make sure you've got this one done. So part of the key of our work here is, again, remember we're in the equations and expressions unit. So key is area of a triangle is 1/2 base times height. If you don't have this step first in your work, then you're not doing the right thing. Alright, so it's half of its base, which we count as 7, times its height, which is 4. So that's half of 28, which would be 14 square units. Alright, so this next one asks you to find the area of the quadrilateral 2 different ways. So when we're talking about the 2 different ways, one way would be to create a rectangle around it and subtract away the areas of 2 triangles. We'll call them just triangle S and triangle T. A different way to calculate it would be to take this shape and see if we can't break it down. Let me get my extra stuff out of the way here. And to break it down, and now I can see that a different way I can break this down is into pieces that I can add together. So I have a rectangle here, a triangle here, and a triangle here, that I could add them all together. So go ahead, find the area of this rectangle, of this trapezoid in 2 different ways. Make sure that it's very clear in the space that you're using. This is where we're kind of looking for who can do the best job of making incredibly clear the work that they're doing in such an organized fashion. So work with your team to not only solve this 2 different ways, but also organize your work so that it's very usable. Make sure that you've paused the video and you and your team have this down before I go ahead and get started. So I'm going to start with the additive way, the way that I've currently got it drawn out here. So I see this is going to be the area is going to be equal to the area of S plus the area of R plus the area of T. Now, there's a couple different ways you can organize your work. One way to organize your work would be to go ahead and put this all into one equation. Area is equal to, well, the area of S would be 1/2 of base times height, plus the area of R would be a base times height, plus the area of T, the area of T is also a triangle, so it would be 1/2 base times height. Now I have to go plug in the base and height for each of these pieces. This base and height would be 1/2 of 2 times 4. For the rectangle, it's a base of 2 and a height of 5, and so it goes. Looks like I miscounted over here. 2 times 5. So this is 2 times 5. And for my third triangle here, over here on the right hand side, it's half of a base of 1 times 5. And going through and calculating those out, this would be 5 plus 10 plus 2.5, which is a total of 17.5. Alternatively, you could have found each of those areas separately using their own separate equations in different spaces, and then just come back and plug into the original equation. That's another kind of way you could have gone about showing your work with this additive method. All right, the other method I'm going to use is by putting a rectangle around it, and I'll just call this Q and P for these 2 triangles that I have here, and I'm going to say that my area is equal to the area of the rectangle minus the area of Q in the area of P. So it's like I'm taking those two parts out. So again, I could show my work the same way. This time I'm going to just show it just a little bit differently. I'm going to just do all the work individually off to the side. Area of the rectangle is base times height. The base and height of this rectangle I've drawn around 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5 is 5 times 5, which is equal to 25. So I can go put that piece into my equation. And area of Q is 1/2 of base times height, which is half of 2 times 5. Which is equal to 5. So minus Q would be 5. And area of P is also 1/2 of base times height. And the base of this one is 1, and the height is 5, which is 2.5. Calculating that all out, and I still get 17.5. So good check. No matter whether we use this as an additive process or a subtractive process, we both get the same value. All right, so let's move on to the next problem here. All right, this one tells us the area of a triangle ABC is equal to 14 square units. Find the lengths of the side BC. All right, so obviously we can see that we can estimate that, but we actually don't know, because you can see that they haven't given us the crosshatches on this to actually label what this length is. So this is where we really have to go back to using our equation. So if my equation is area of a triangle is equal to 1/2 of base times height, with your team, measure the pieces that you can, find out what you can plug in for, plug in the information that you can, and then if need be, go ahead and solve the equation. Alright, so we plug in the pieces we know. We already know the area. So the area of the triangle is 14. That's going to be equal to 1/2 of the base, which we don't know, but we can count out the height here is 1, 2, 3, 4, 5, 6, 7 times 7. So rearranging this, I'm going to get that 14 is equal to 1/2 times 7 times b. That's going to be 14 is equal to 3.5 times b. Well, we know what to do now in terms of solving this. Divide by 3.5. Divide by 3.5. It gives me 4 is equal to b. And finally, it says find the area of the regular triangle ABC. So we can see here that there's nothing here we can measure as a base and height because they're all coming across these particular shapes. So what we end up having to do is they've set up for us here a rectangle that we can use, and then there are 3 triangles that you can take away. So label them however you want. Maybe call it triangle A, triangle B, triangle C. And go ahead and see if you can't determine with your team the area of what would be left over after you take away triangle A, B, and C. Call this T, area of T. Alright, go ahead and see if you can figure that out. If you need a hint, I'll give you a hint here in a second, but go ahead and pause the video and see if you can't get it done without the hint. Alright, your hint here is that the area of T would be equal to the area of the rectangle minus area A minus area B minus area C. So hopefully that should be enough to get you going. Alright, as I move through here, I'm going to go ahead and replace the area rectangle, base times height, Area A is a 1/2 base times height since it's a triangle. Area B is also a triangle, so it's also going to be 1/2 base times height. And area C is also going to be a 1/2 base times height. Alright, the base times height of the rectangle, counting it out, looks like it is going to be 6 and 11 times a height of 10. Triangle A would be half of 10 times 6. Triangle B would be half of, counting that out, 1, 2, 3, 4 by 2, 3, 4, 5. And half of C would be 11 by 1, 2, 3, 4, 5, 5. Alright, so this is going to be 110 minus 30 minus 10 minus 27.5. I'm going to do these a couple at a time. This part will give me 70 minus 27.5, which is going to give me 42.5 square units. Right, as I go back, it looks like I miscounted up here. This should have been a 7, which would make this 35, which would make this 65, and would make this 37.5. Alright, quick corrections there. Alright, but that's the work for today. Please go ahead and flip on over now that you and your group have totally figured out. If there's somebody in your group who looks a little bit confused before you move on to your alone time, please make sure that they know what's going on. Once you move on to your alone time, everybody should be working independently, showing what they know as individuals, not what you know as a group.